In this video, we're going to be talking about factoring. So let's just, hopefully you've reviewed the examples in your textbook, and we're just going to do a couple of extra ones. Specifically, we're going to focus on trinomials, not necessarily factoring out monomials or factoring by grouping. So first one, factor completely or state that the expression does not factor, and that's always a possibility. So for those of you who have a good number sense and you can just know when a polynomial factors, that's great. But if you aren't one of those people, there is a step-by-step process for determining when an expression like this factors. So let's just go through the steps. Step number one is to multiply the first and last terms together with their signs. Okay, so first and last, first of all, the polynomial has to be written in general order. So the highest power of x comes first, then the next lowest, etc. So these are in decreasing powers of x. And then you want to take the biggest one and the smallest one and multiply those together. And because this was a minus 8 at the end, we're going to use negative 8 as our answer. So it's important to take the sign as well. So 7 times negative 8, that's negative 56. And then x squared, right, because we had this x squared. So this is their product. That's step number one. And step number two, and by far the most difficult step, is to find two things that multiply to give you this negative 56x squared that you got in the first step and combine to give you this middle term, this negative 10x in this case. So I'm going to go ahead and color code this. And what we want here is the same thing that goes here needs to go here, and the same thing that goes here needs to go here. So we're looking for expressions that go in these red and green blanks such that both their product is going to satisfy this and their sum is going to satisfy this. Now, this is, like I said, the hardest part. So let's just think about a systematic way you can do this. This negative 56, let's just ignore the fact that it's negative for a second and just think about 56. We need two numbers that multiply to give us 56. Okay, so let's just make a little note over here. Now, there are a lot of ways you can get 56. For example, 1 times 56. But are you going to be able to combine 1 and 56 in a way that's going to give you 10? No. And when I say combine, I mean you need to be able to add or subtract them from each other and get this number. So that's not going to work. Okay, what about if you take 56 and divide it by 2? Well, if you divide it by 2, you get 28. But can you take 2 and 28 and combine them in some way to get 10 or negative 10? No, that's not going to work either. Okay, so what about 3? 3 doesn't actually even go into 56 evenly, so that's definitely not a candidate. Okay, but you can see what I'm doing. I'm just literally testing all the options. Okay, so how about 4? Does 4 go into 56? It turns out it does, and you can do this with a calculator or however you want. 4 goes into it 14 times, so that means 4 times 14 is going to be 56. Now, can we combine 4 and 14 in a way to get 10? That looks kind of promising, right? I mean, we'll have to be careful about our pluses and minuses, right? Which one's positive and which one's negative, but this looks like it's going to work. So this is what's going to go in these two spots. Okay, so one of them is going to have to be negative, right? This 4 and this 14. If we want it to be negative 56, one is going to have to be negative. So what I'll do is say put the 4 here, and put the 14 here. And because we need this to be x squared, but they also need to be able to combine together, they both get a single copy of x, right? Because then when we multiply them, we'll get 2 copies, but when we add them, they'll be like terms, and they'll be able to be put together. And let me go ahead and write these here as well. Right, so the green term is 14x, red term is 4x. But we've ignored so far the fact that we need these negatives. I mean, in fact, neither of these is even true yet. So we need one of them to be negative, but hopefully you can figure out based on these two numbers what we need to be negative. In particular, this negative 10x. So which one should be negative? This 14, of course, should be negative, right? Because 4x minus 14x will be negative 10, or plus negative. And by the way, I recommend you leave this plus in the middle and just take the sign with the number. That ends up making things easier, usually. So 4 times negative 14 is negative 56. 4 minus 14, that's negative 10. And both of these things are true because of the way we placed our x's. So like I said, this is the hard step, but it's really, you can just do it by brute force, right? Just check all the options. Okay, so then what you want to do is replace the negative 10x in your original expression with these two terms. So what I mean is our original expression was 7x squared minus 10x minus 8. But instead of writing minus 10x for us, we're going to write plus 4x minus 14x minus 8. Because really these two together are the exact same as the original middle term. So we haven't actually changed the value of this thing, we've just changed the way it looks. And then what we want to do is factor by grouping. Okay, so we're going to group these two together, and we're going to group these two together. So factor by grouping. We've got 7x squared plus 4x. What do they have in common? Well, 7 and 4 don't have anything in common, but x squared and x, we can take an x out of that, right? And that'll leave us 7x plus 4 in the original expression, right? Because if we were to distribute this x, we would get 7x squared plus 4x. So we factored out an x there. And the trick here is, in the second part, is not to just choose anything that can be taken out, but specifically something that can be taken out that will leave what's in the parentheses as an exact match to what we got the first time. So here we've got this 7x plus 4. So we want to be able to pull out something such that we leave behind 7x plus 4, if that's possible. And if you did step 2 correctly, it will always be possible such that we can leave behind 7x plus 4, whatever you got in this first expression. Again, if you did this second step properly and you could find numbers that made this work, you should always be able to do this in this next step. So the question is, what goes here? Right? We need something that fills in this gap. So what can you take out of negative 14x minus 8 that's going to leave 7x plus 4? A negative 2, right? Because negative 2 times 7x, that'll be negative 14x. Negative 2 times 4, that'll be negative 8. Let me just move across this line here. Now the last thing we want to do is, now both of these terms have a 7x plus 4 in common, so we're going to factor that out as well. So we take the 7x plus 4 out of this term, and we're going to get just an x left behind because we pulled this term out. And then we're also going to take 7x plus 4 away from this term, which is just going to leave behind this negative 2. And this is the factored version of this original expression that was in teal here. And you can check it. Factoring problems are great because they're easy to check, right? Just do this multiplication and see if you get the original. Okay, now let's look at one that's a little more specialized. Factor completely or state that the expression does not factor. Now this one is not a trinomial, meaning there are not 3 terms, but that does not mean that it can't automatically factor. Also, x to the 4th and 16 don't actually have anything in common, right? It's not like above where we could just take out an x from this 7x squared and 4x. These don't have an x in common. They don't have anything in common, except that they're both perfect squares. And it turns out that having a difference, specifically this minus sign has to be here, a difference of squares, means you can factor. And what you're essentially going to do is say, if you have a perfect square here and a perfect square here, then the square root of this term goes in the first 2 spots, and the square root of this term goes in the second 2 spots. And you connect one with a plus and one with a minus. And again, this should be addressed in your textbook, but let's just go through this. So what's the square root of x to the 4th? Right, so square root of x to the 4th. So that's going to be x times x times x times x, and every 2 of these can come out as a single copy on the outside. So these are just a single x outside of the root, and then these are just a single x outside of the root. So it turns out that this is x squared. So that's what's going to go in the first 2 expressions. The square root of the first term goes in the first 2. And then the square root of 16 is 4. And then we're going to give one of these a plus and one of these a minus. And essentially what we've done is made sure that if you were to multiply this back out, the outer term and inner term are going to cancel each other out. So you can check that when you do actually multiply this, you get this expression here. But this one is a little extra tricky because we're not done yet. Notice how it says factor completely. Well, this one's fine. We can't factor this, right, because it's a plus sign in the middle. But this one has a minus sign in the middle, which means you need to watch out to see if this is also a difference of squares. And it turns out that it is. So we're going to take this x squared plus 4, but this term can be factored into 2 different expressions in the same way that we just factored the original. So if you want, you can pause the video and try and figure out what should go in these 2 spots. Okay, so it should be the square root of x squared, so that's going to be x in the first two spots, and the square root of 4, that's 2 in the next two spots, and again, one gets a plus and one gets a minus. Okay, so now we are actually done, because these have pluses, and if there's only two of them and they don't have anything in common, and they're not connected with a minus, nothing can happen here. So this is completely factored. And then again in this one, there's only two expressions, there's only two terms, they don't have anything in common, and they're connected with a plus. So this one's done as well. Now we go here, there's only two terms, they don't have anything in common, but now they're connected with a minus, so you need to ask yourself, is this a difference of squares? But 2 is not a perfect square, and x isn't a perfect square either. So now we are truly done. So this is what it looks like in factored form, and you can check, again, if you just multiply all these out, you should get the original. Now let's do one more example. Factor completely or state that the expression does not factor. So again, we're going to use the same method that we used for the first example for doing trinomials. So step 1 is to multiply the first term and the last term together. So x squared times a positive 1, right? That's just going to give us x squared. And then the second step, which is the hard step, we want to try and find two things that multiply to give us x squared and then combine to give us the middle term, which in this case is just x. Now, remember, we want to find something such that what goes in these first spots matches and what goes in these second spots matches. Now, remember last time we were dealing with 56, and we didn't actually really mind the x squared very much, because we know if these things multiply to give you x squared, but then combine to give you something that only has a single power of x, you're going to have a single copy of x in each of these, so that they're like terms in this second expression, and you can actually put them together, right? Which we're supposed to be able to do. But now we're in trouble, because x times x just by itself is already x squared, which means we can't put numbers in front of these things. But now x plus x is not equal to just x, right? Ideally, we want to find numbers that will make this expression true, but now we've already got the numbers that make the first expression true, but those same numbers don't make the second expression true. Okay, so it's impossible to actually get a solution to this, which is exactly why the instructions say factor completely or state that it does not factor. So this is what it looks like when it doesn't factor. When you get to step 2, if you can't actually make these equations work, that means that this thing can't be factored. Okay, so you would just say does not factor. So like I said, step 2 is the hardest. It's also the one where you make the decision about whether or not you can actually factor this thing. Because as I said in example 1, if you can do this in step 2 correctly, you should always be able to do the rest.